Hi everyone. Let us start our lecture series on IoT and its applications. Myself, Dr. Kishore, Department of Electronics and Communication Engineering. Agenda of this lecture series we followed by objective and outcome, syllabus, introduction to the IoT technology, and origin of IoT, evolution of IoT, and definition of IoT various domains, need and implementation of IoT, characteristics of IoT, and architecture and key components of IoT. So when you come for this course, the course code is 2450407. The objective of this course uh, is to introduce IoT architecture and standards, IoT communication protocols, sensors and actuators, data analysis, and practical IoT applications. So students has to learn these are the basic things about IoT when they're going. So when you come for outcomes of this course is student can able to describe the IoT architecture and protocols, and they can communicate different communication protocols which are available in IoT and how they can be used, and they can able to integrate different sensors and actuators for IoT applications, and they can also analyze the cloud data using cloud data and security options for IoT data, and finally they can able to define and design one IoT application for real-time applications. So when you come for the syllabus, which is divided as a 5 modules, where the module 1 tells you about the introduction of IoT, and module 2 is an IoT communication protocols, where module 3 is a sensors, actuators, and embedded systems, where module 5 is data management and analytical and security, and module 5 is an application. So when you see the syllabus flow, in the first module, all students can able to learn the basic definitions of an IoT applications and different standards. And when you come for the second unit, IoT communication protocol, student can able to learn what is the different protocols which are available. And because we know that communication protocol is a media between any devices, how different protocols are available, how they can be used. And when you come for a module 3, the students can able to design a small applications with embedded systems like a Raspberry Pi or an Arduino with different sensors and activators, how they are connected, and they will do some experiments like how an LED can be interfaced with a Raspberry Pi with an LED and a switch, and similarly interfacing of a light sensor with a Raspberry Pi. When you come for the module 4, data management and analytical security, here the students can able to learn and cover entire IoT cloud data information, how the data will be connected to the cloud, and big data analysis. And come for unit 5, IoT applications, where the students can able to know some particular applications where how IoT can be used. So for an example of smart home applications, smart cities, health care, and real logistics environment, and etc. So when you come for introduction of IoT, Kevin Ashton is a person that coined the name term Internet of the Things. So when he working as a presentation for Procter and Gamble in 1999, he found the name called Internet of the Things. So he said that Internet of Things is about empowering a computers so that they can see, hear, and smell the world themselves. So he envisioned a world where the physical objects embedded with the sensors and communication technologies could automatically collect, exchange, and process the data over internet with a minimum. So in his word, a simple way we can say that IoT is nothing but a smart devices, a plus a sensors, plus internet and some data processing with a intelligent decision making is called as an IoT. So when you come for a current and history of IoT, the IoT was as introduced the term in 1999, and 2020 we have 8.7 billions of IoT devices connected worldwide. When you see in 2026 now up to we have an 18.80 billions of IoT devices. The vision that when you reaches 2030, there may be a possibility of 31.08 billions of devices, IoT devices connected worldwide. And similarly, when you say summarizing this future Summarizing this, 31.8 billions of IoT devices connected worldwide, 2 trillions of global IoT is the market size when you go for 2030, and 3.57 connected devices per person will be there. So, general, what is it? Internet of a Thing, IoT, is a network of interconnected physical devices embedded with sensors, actuators, processors, and communication technologies that collect, exchange, and analyze the data over an internet, enable an intelligent decision making, automation, and real time monitoring with a minimal human interaction. So, these IoT definitions is given a various, suppose internet of things is a broad concept, and various organizations and standard bodies have defined it from slightly different perspectives. In case if you see about ITU, International Telecommunication Unit, which has defined that the infrastructure of information society enabling advanced services by interconnecting things based on the existing and evolving interoperable information and communication technology. When you see IEEE form, they defined IoT as IoT is a paradigm in which objects of every life are connected to the internet and can identify themselves to other devices, enabling them to communicate and exchange data over common goals. So similarly, IETF, Internet of Engineering Task Force, they defined IoT refer to a network of devices that are embedded with the sensors, softwares, and other technology to connect and exchange data over the devices and systems over the internet. Similarly, W3, the IoT worldwide network of uniquely addressable things connected to the internet, where things can communicate, interact with each other, with the people, and where the data is collected and exchanged. And finally, ISO and IEC has defined IoT is an infrastructure that enables the interconnection of a physical and virtual objects through internet, allowing them to collect the data. So, is the IoT only term used to connect the devices? Of course, IoT may have a related relevant technologies that are named each and for different applications. For an example, these are the some devices which are similar to IoT with depends on an application. The name is going to be changed. Similar, first one is an IoT, second one is a mission to mission, third one is an Internet of Everything, fourth one in the industrial of Internet of Things, embedded Internet, Web of Things, vehicle to everything, Internet of intranet of the things, and things that things. So we'll see all these things in the next slide. So different names, different focus areas, all work together, build a smart, connected, and intelligent world. So when you come for a concept of Internet of Things, the Internet of Things IoT is a network of a physical devices that collects the data using a sensors, communicate through the internet, process the information, and perform. For an example, if you take a smartwatch, the smartwatch, how it is automatically reading our heartbeats. So which is reading our heartbeat using a sensors which will be sent to through the cloud through a internet. From the cloud, it analyze the previous data and return back as an alert to our home, our mobile, our smartwatch again. So in simple way, you can say that things plus sensor plus internet plus intelligent is called IoT. When you come for the second call as a mission to mission, in this M2M refer to a communication between two or missions can communicate without a human interactions. Missions exchange data automatically. For an example, if you take a smart electricity meter sending a reading to the utility companies, or ATM can communicate with the bank server, vending machines reporting to the low stock. So in the all these applications where one mission can be communicate with another mission depends upon data, exchange the data automatically without an human interaction. So what is the major difference between M2M and an IoT? M2M usually communicate directly between the mission to mission using a dedicated communication technologies, where IoT extends this by connecting a mission to the internet and cloud services. So next one is an Internet to Everything. So here Internet to Everything is the name introduced by the Cisco, where as we see that internet of things can be connected to the things, but here IoE, internet of everything, will be connected with the people, data, process and things, not only the devices which can be. So here we see the differences clearly mentioned. IoT connect to the things, where IoE connect the people plus things plus data and processing. For an example, if you take one example, day to day we are watching our traffic light signals, where the traffic light signal, someone jumps the signal, camera will be automatically record whoever violating the traffic rules persons, which will be informed to the police, and in case of any accident occurs, it will be informed to the hospitals. So we here all the people to the things which is automatically done by using a internet of everything. Next one is an industrial application. So industrial IoT, where industrial IoT will focus on only within an industry range. For an example, manufacturing unit, oil and gases, power plant, chemical industries and robotics. In this, in case of any machinery, if you're having a high temperature sensors, the data will be sent to the cloud, and cloud return that value to the predictive maintenance system. So immediately maintenance engineer will be respond to that. So this industrial internet will be work within an industry for all these applications. So what is the benefit of it? Will be reduce the downtime, high productivity will be introduced, low maintenance by introducing IoT in industrial areas. Similarly, embedded internet. This is the one because everyone knows that embedded system is a small computer built inside a devices. Whenever these embedded systems are connected to the internet, then they become an embedded internet. For an example, if you take a washing machine, Wi-Fi controlled washing machine. So in this washing machine, we can control or we can set all the values by using our mobile by connecting a Wi-Fi. Similarly, smart AC, smart TVs and smart ACs what we are using now a day-to-day lives. In smart TV can be connected to the Wi-Fi, where you can change your channels or you can set or everything from your mobile phone, which is connected to the cloud and cloud to the your smart TV. Similarly, the smart AC. So next one is Web of Things. So Web of Things WT uses the standards web technologies to access IoT devices instead of using a general protocols device export. So actually what is this WT? WT is a convergence of IoT and web technologies. It makes smart devices discoverable, accessible and manageable using a same tool use a web browser. For an example, this web of thing, using a web services, you can control, you can find and you can enable any applications, any IoT applications using an web of things only, website only. For an example, tools which used in HTTP, REST APIs, JSON and WebSocket. These are some tools. Using any one of the tool, you can control the temperature, light, fan or these from smart applications, not from your mobile phone, from your website only or a web thing only you can. So how it will be? You can open your browser sends the request, HTTP request to the server, and device performs the action and displays the action into your system. So next one is a vehicle to everything called as a V2X. So which is generally using vehicle to vehicle communication technology. When modern vehicle communicate with many entities around using a wireless technologies. So vehicle to V2X enables this road safety, smarter traffic and smarter mobility for everyone. So where in this vehicle to everything, vehicle to vehicle communication can be taken place, because when you are riding some vehicle, if you suddenly brake, so that backside vehicle will be connected to your Wi-Fi devices, so that it will be automatically brake, so that accident can be avoided. So there's some type of V2X technology called as a vehicle to vehicle technology, vehicle to the infrastructure technology, vehicle to the pedestrian technology and vehicle to the network. So next one is an intranet of the things. If you use web internet within a system or within one area, sometimes IoT device can communicate only inside of one organization, where the no internet, which is connected only to the local network called intranet. In an intranet, connected device shares the data and services with a private network, secured, efficient, and control the communication. If you take an example, suppose inside an hospital, patient monitoring system is connected and nurse station connected to the local network, which is connected to the ventilator or imaging system, so that data can be transferred within the network, so that privacy will be increased. Similarly, inside a company, access control, biometric access control connected to the employment data, and which can be communicate each. Next was things that can be think. So this refer to the device that uses artificial intelligence instead of simple collecting a data by learn, predict, and make a decisions. So for an example, AI powered robots, smart cameras, intelligent drone, self-driving cars. So these are all the examples of things that can be connected to it. And next one is need and importance of IoT, a Internet of Things that connects the physical devices to Internet, enabling them to collect, share, and act the data. It transforms the way we live, work, and interact with the world. So, what is the need of this IoT? For real-time monitoring control, improve the efficiency and productivity, cost saving, better decision making, enhanced customer efficiency, and sustainable and resource management. So these are the things which we require need of an IoT. So what is an important of IoT? So this IoT can be used in a smarter cities, healthcare, agriculture, industrial IoT, smart cities, transportation, and real time. So IoT is not just a technology, it kinds enable of smarter, safer, and more connecting to the world. So what are the key characteristics of this Internet of the Things? IoT systems are more intelligent and powerful because of the following essential characteristics. The IoT systems are dynamic and self-adaptive, which means that IoT device and systems can dynamically adapt to the changes, context, and take the action based on an operating conditions. They sense the environment, analyze the changes, and respond automatically. If you take an examples of smarter AC, which is connected to the Internet of Things. So whenever your room temperature raises more than 30 degrees Celsius, the AC is automatically turned on. And whenever your room temperature which is reduces the below 24 degrees centigrade, again AC is automatically turned off without an human. That is called as a dynamic and self adaptation. So self configuring. So the devices can configure themselves with a minimum human interaction. They connected to the network, set up parameters, and fetch the latest software automatically. As we are seeing that our smartwatches will be updated automatically without. So any, because it is continuously connected to the internet, so whenever any new updates are coming inside the cloud, so your without your intimation or without your small permissions, it will be self configured automatically. So next one is interoperable communication protocols. So these IoT device supports various interoperable communication protocols, so they can communicate with other devices and infrastructure seamlessly and ensures a compatibility across the devices and platforms. So next one is unique identity. Each IoT device has unique identity. So for an example, IP address or a MAC address or UIDs. So enable secure identification, addressing and management purpose. Individual devices will be assigned with a unique identity and integrated into the information network. So these IoT devices are integrated into the information network to exchange the data with other devices, applications, and systems. So they can be discovered, monitored, and controlled through the network. In summary, IoT intelligent, autonomous, and connected to the interoperable, making the foundation for a smarter applications in home, cities, industrial, healthcare, and agriculture are many domains. So what are the key components of this IoT? So when the key component of IoT are the mainly called as the sensors, actuators, gateway, and cloud platforms. So when you see the sensors is nothing but we have some examples are given a different sensors, which is a temperature sensor, humidity, motion detector, light sensors, gas, smoke, smiles, and these are the different sensors are available. Depends upon an application, the sensors will be used. And the second major component is called as a gateway. So the main function of this gateway is to protocol conversion, data filtering, local processing, security, and sends the data. For an example, Raspberry Pi, ESP32, Cisco IoT Gateway, and edge computing. Similarly, the cloud platforms is the brain of an IoT. It stores, process, and analyze and manage the data over the devices. So the main functions is data storage, data analysis, machine learning and AI, which is used to analyze your data, device management, alert and notifications, dashboards. So for some of the example called as an AWS IoT Care, Microsoft Azure IoT, Google Cloud IoT, and ThinkSpeak and Blue. So activators are the hands of an Internet of Things. They receive the commands and they perform the physical actions. So for example, motors, relays, servo motors. So simple way you can say any output devices will treat as an activators. So architecture of IoT. So IoT architecture defines how device sensors, activators, gateway, cloud platforms, and applications work together, collect the data, process, and deliver the valuable insights. So this is a simple architecture. Starting step one, stage one is called as an device, where you have a sensors and activators will be there. Second part is a gateway and the communication network which transmit data between the devices and gateway. For an example, if you take Wi-Fi, 4G, LoRaWAN, Ethernet, some communication protocols which we are going to see, in our second unit, and cloud platforms and application layer. So from today's lecture, what we have learned is what is an IoT, why IoT emergence, history and evolution of IoT, and various definitions from various standards about IoT, and need and importance of an IoT, and characteristics of an IoT, and the IoT components, architecture of IoT. So thank you.